Show the mechanism for the nitration of benzene. So nitration means that we're going to have to use nitric acid, HNO3, and sulfuric acid, H2SO4. Alright, step 1. You have to have an electrophile, and the electrophile is produced when nitric acid reacts with the sulfuric acid. So nitric acid is this: nitrogen, double bond, O, O, there's a minus there, and OH, and we have a plus charge there and a minus charge on that oxygen, a plus charge on that nitrogen. And you know that H2SO4 is one of the 7 strong acids. So in solution, H2SO4 becomes H plus HSO4 minus. Alright, so this is what happens. You have a lot of H pluses floating in solution. Yes? So H plus. So one of the lone pairs on that oxygen grabs that H plus. And this is what you get. Nitrogen, double bond O, oxygen, 3 lone pairs, negative, O, and you have that H there, and you have that lone pair there, but now that lone pair is now a bond, and you have that H. If you do the formal charges, you have a plus charge on that oxygen, and of course you have a plus charge on that nitrogen. So you have a plus charge right next to a plus charge. Very, very unstable. So what happens is this here. Alright, so this is step 1. Step 2. So this is our starting material for step 2. And double bond O, single bond oxygen, 3 lone pairs negative, oxygen, H plus. Alright, so a plus charge right next to a plus charge. So what happens is this leaves as a water molecule, and while this is leaving, this one of the 3 lone pairs on that oxygen helps out by forming a second bond between that oxygen and that nitrogen. And this is what you get. So you are forming H2O, and you are forming the nitronium ion. So nitronium is N, double bond O, double bond O, and you still have a plus charge on that nitrogen, which will be stabilized by that HSO4 minus. So HSO4 minus to stabilize that plus charge. Alright, so in the process we have created the electrophile. That's very, very electron deficient. Yes, and this is now the species that will be attacked by that benzene molecule. So step 3. Step 1, step 2, step 3. So now the benzene with an H there will react with the electrophile, which is the nitronium. And double bond O, double bond O. We have a plus charge there, 2 lone pairs on each nitrogen. Alright, so what happens is that bond, so the benzene loses its aromaticity, it grabs that nitronium, and you get this intermediate. You still have that H there, and additionally, in addition to that H, there will be another covalent bond at that carbon, this time bonded to that nitronium. So N, double bond O. Alright, since you are creating a bond between that carbon and that nitrogen, this here is going to have to go to that oxygen as a 3rd lone pair. of electrons. Yes, so O, two lone pairs there, or three lone pairs rather. You have a minus there, and you have a plus there. Oh no, there is no. Hold on. Yeah, you have a plus charge there, and additionally you have a plus charge here. Okay, because you lost the aromaticity. You have 4 attachments to that carbon. Now you only have that bond, and this H. It's not showing, but you have an H there. So therefore we have a plus charge at that carbon. Alright, so step 4. This is what happens. Step 4. So we start with this. By the way, that plus charge will be stabilized by the HSO4 minus. HSO4 minus. Okay? Alright, so step 4, we start with this. We have, oh, nope. We have an H there. We have the N, double bond O, single bond O, minus. We have a plus charge there. We have a plus charge there. Alright, so this is what happens. So you have that hydrogen sulfate floating, HSO4 minus. The benzene ring wants to reestablish its aromaticity. So what happens is that HSO4 minus, it's got that minus sign, will grab that H so that that bond between that carbon and that hydrogen goes between that carbon and that carbon, thereby re-establishing aromaticity of the benzene ring. And finally, you have your nitrated product, HNO2. Oh, no. Yes, we have a plus charge at that nitrogen, we have a minus charge at that oxygen, so therefore we have a neutral molecule.